trig substitution. There are three cases. The case one, if your integral involves something like a square minus u square, where a is a number and u is a function, then you want to make the substitution u equals a sine theta, okay, and theta is in between negative pi over 2 to pi over 2. And once you make this substitution, then take the derivative with respect to theta, so du over d theta equals a, derivative of sine is cosine theta d theta, okay. And you will be using the following identity: 1 minus sine square theta is cosine square theta. For example, you might have 9 minus x square in one of the integrals. In this case, a is 9 means 3 squared, a is 3 and u is just x, okay. And you want to make u equals a sine theta, that means x equals 3 sine theta, and you take the derivative of x with respect to theta, so 3 cosine theta d theta, that will be the case. Now the purpose of making this substitution is to get rid of this square root, okay. Then 9 minus x square will be square root 9 minus x. X is 3 sine theta. 3 sine theta quantity square, that's 9 sine square theta, and 9 we can factor out 9, then leaves 1 minus sine square theta. Now we have times here, square root of 9 is 3 and 1 minus sine square is cosine square, and the square root of cosine square is cosine theta, okay. That's the purpose of making this substitution. Now we don't have a square root anymore. Let's take another example. Let's see, we have a square root of another example. Let's say 16 minus 9x square. In this case, a is 4 and u is 3x, because 3x quantity square, this is 4 square, and we want to make the substitution u equals a sine theta, that means 4 sine theta, that is u is 3x, so 3x equals 4 sine theta, and we need the differential later, but we which is take the derivative of left side with respect to theta, we get 3 dx equals 4 cosine theta d theta, okay. And you can find dx from here, and this root 16 minus 9x square then becomes 16 minus 9x square is 3x quantity square, and 3x is, by the way, 3x is 4 sine theta, so 3x quantity square is 4 sine theta quantity square, 4 sine theta quantity square, which is 16 sine square theta, and inside the radical sign we can factor 16 out, 1 minus sine square theta, which is square root of 16, that's 4, times 1 minus sine square is cosine square, and square root of cosine square is cosine theta. This is how we can get rid of the square root. Case 2, let's try the form, okay. Let's say case 2, if the integral involves the root of a square plus u square, or we can switch, or u square plus a square, then we are making the substitution u equals a tangent theta, where theta is strictly bigger than negative pi over 2 and less than pi over 2. Okay, and the identity we will be using is 1 plus tangent square is secant square. Okay, for example, let's take one example, root 4 plus 9x square. In this radical, in this root, a 4 is 2 square, so a is 2, and 9x square is 3x quantity square, so 3x is u, so u is 3x. We have this form. Now we want to make substitution, u equals a tangent theta. Okay, so u equals a tangent theta. Let me make it over here. U equals a tangent theta, and u is in fact 3x equals a is 2 tangent theta, and you take the derivative of x with respect to theta, you get 3 dx equals 2, and derivative of tangent is secant square theta d theta. Okay, with this substitution we should be able to get rid of this square root. Let's, with this, our 4 plus 9x square now becomes 4 plus 9x square is 3x quantity square, and we are writing 3x equals 2 tangent theta, so 2 tangent theta square, which is 4 tangent square theta. And now we can factor 4 out, that leaves 1 plus tangent square theta, and square root of 4 is 2, 1 plus tangent square is secant square, and square root of secant square is secant theta. That's how we get rid of this square root. Now the third case is square root of u square minus a square. If we have a square minus u square, that was the case 1. Okay, in this case we make this substitution, u equals a secant theta, okay, to get rid of this square root. You will see in a moment. And the identity we will be using is secant square minus 1 equals tangent square. Okay, let's take an example. Suppose we have 4x square minus 9 in question, in the integral we are trying to evaluate. In this case, u square means 2x, and a is 3. Now we make the substitution, u equals a secant theta, which is 2x equals 3 secant theta, and we have to take derivative of both sides with respect to theta, so 2 dx over d theta equals 3, and derivative of secant is secant tangent d theta. Okay, now let's go back and work out with this root 4x square minus 9. That's now 4x square is 2x quantity square, 2x is 3 secant theta, so 2x quantity square is 3 secant theta square, that is 9 secant square theta minus 9, and we can factor 9 out from these two terms, and we get secant square theta minus 1, and square root of 9, that's 3, and we get square root of secant square theta minus 1. Secant square theta minus 1 is tangent square, so square root of tangent square is tangent theta. That's how we get rid of the radical sign. Okay.